स्टार्ट हो रहा है। हाँ, हंसी वाली चीज दिया हूँ।
Hi guys. We are about to start. In about 5-6 minutes, we're going to start. So I'm just waiting for a few more people to join. Around 40 people have already joined. I'll be taking this webinar, and along with me here, Rishabh is also here. Here you can find him on the chat. So there's Rishabh. So if you're asking something on the chat, so Rishabh will be helping you out with that. Okay. प्रतीक भैया भी है यहाँ पे.
Hi guys. Hello everyone.
Okay, just wait for 2-3 minutes. I am about to start. Okay. Hi. Today we're going to talk about using Kotlin in Android. So we will break this thing down. Basically, what we're going to do is we will first of all we're going to take some time doing Kotlin basics. Okay. So we will spend some time understanding the syntax of Kotlin. We'll see how functions work, how objects work, how classes work, all of that stuff. Then there was this repository that I had already mentioned to you, which was on this URL cb.lk/cotprep. There is a Git repository on which there is somewhat sort of half-made Android app. So check out the Java branch on that. The Java branch has got only Java code right now, so that is something that all of you who know Android development already, you'd be able to understand that part, right? And then what we'll do is we will take a look at what are the places inside an Android app where when we Kotlin we can improve upon our code. Sometimes we can reduce the amount of code that we are writing. Sometimes instead of creating classes, we can use some functional programming and improve the way we are dealing with data and all of these things. So I will just go through the steps that I have performed to create the app to the current level. The Java app has a lot of code, so I will not write that down all over again during the webinar, but I will move through the steps. It has step-by-step commits are there, so I will move through each steps and I will just describe how the recycler views are made, the adapters are made, and how I am getting data from retrofit and showing it on the screen. Then we will hands-on code and convert that entire app into Kotlin and see all the places where we benefit from using Kotlin in Android. And while doing that, we'll also use some extra Kotlin functionality for Android, which is part of the Kotlin Android extensions. Okay, so then we will convert that app into Kotlin. Okay, these are things that we will do. So to start with, let us discuss a bit about Kotlin itself. What is Kotlin? So Kotlin is a language that has been developed by the JetBrains team. So JetBrains, the guys who make IntelliJ IDEA, on which Android Studio is based. Okay, so what is special about Kotlin is it compiles to bytecode. So basically that means that it runs on the JVM. Since it can run on the JVM, it means that it can run on Android as well, because Android does not exactly use the JVM, but if you can convert something to Java bytecode, you can convert it into a Dalvik executable, and a Dalvik executable can be run on Android, right? So that is what Kotlin is about. Kotlin of late, the Kotlin team has also added support for Kotlin JS and Kotlin native, which means in the future you can write code in Kotlin and compile it to native like a C++ program, or you could compile it to JS so that you can write some web front-end related stuff also inside Kotlin. So Kotlin is just the language. Kotlin does not mean that it is supposed to run only on Java. The compatibility with Java and with JVM is really strong here. So it has Java interop. So Java interop means that we can declare classes in Kotlin, use that in our Java program, and we can declare classes in Java and use that in our Kotlin program. It is because at the bytecode level, they are going to run in the same place. So we can interoperate between Java and Kotlin, right? If we are using Kotlin for Android, so we will need to use a plugin called Kotlin Android, and additionally we will use a plugin called Kotlin Android extension. Now both of these are additional libraries on top of Kotlin, which enable a very easy ways Kotlin inside your Android apps. Now let us move to actually writing some Kotlin code. Okay, so we will do is, let me just open a new project. We will see how you can create a Kotlin project. Now this I'm using IntelliJ IDEA. Any version of IntelliJ IDEA you can use. You can use the community edition, and if you're using anything that is 2016 or above version, we will have Kotlin support by default inside the IDE itself. Then we click on create a new project, you can see that of a lot of options that is available, Kotlin is one of them. So you're going to select the Kotlin Java option, okay? And you can select your Java version appropriately. It's good to stick with 1.8. Kotlin works really good with Java 1.8. Okay. May go ahead and we'll just create it somewhere. Say Kotlin 101 project name, and here we go. So you'll see that Kotlin code we are going to write inside our src folder that has been created here. Inside our src folder, we can start with Kotlin file or class, and let's say we create a hello world. So, is there anyone here who has not coded in Java at all before? You can tell that on the chat if there is somebody who has not coded in Java before. So, because I guess most of you have worked in Java. Now, here's something that's going to change for you. In Java, there is a very strict object-oriented programming concept that every file must have a top-level class, which means if you create something like hello.java file, you need to have a class called hello at the top-level class inside that file, and you cannot have multiple classes inside that. Right? You can create only single top level class, and inside that class you can obviously have further inner classes. Now Kotlin removes that constraint because Kotlin is not designed to use only with object oriented programming kept in mind. We can use Kotlin without object oriented programming. We can actually use Kotlin purely in a functional way as well. So in this hello world.kt, what the basic thing that we require to run this file is we need to create a main function, and you can just type main and tab, and IntelliJ will create that for you. So this is how a function is declared. The keyword is fun. Okay. And as you can see, we need some arguments here. We'll talk about the argument syntax later on, but it is called a Pascal syntax. Pascal syntax means the type is written after the argument, not before the argument. Okay. Like you can see here that array string, this thing is written after arg with a colon. So many languages use this syntax called Pascal syntax. Now let's do the that all programmers do with a new language is we do println. Okay, we do println and hello world. So how do we run this file? You will see that there is a k symbol right in front of this function. You press that and you will see that run hello world dot kt will come up and run this. As such, straight out of the box in IntelliJ IDEA, you do not need to do any kind of setup like Gradle or Ant or Maven or any kind of make files that we use, that you do not need to do. You can straight away start with this, and as you can see, hello world gets printed here. Okay. Now, going forward, let's talk about how variables work inside Kotlin. So we declare variables using either of the two keywords, either val or var. So if I do it with val, and let's say I do val my name equal to, again straightforward, you can see something that is different from Java. I did not specify a type for my name. This works because Kotlin can infer types from the right hand side of the argument. Okay, so my name has become a string, and instead of hello world, I can print my name here. The normal Java plus operator overloading way, you can do my name like this. That is possible. We can run this. Okay. So hello Arnav gets printed. There is another thing is that strings are template strings, so you can escape out variables here. Escaping variables means you can use dollar my name. So that works the same way. Whenever you use dollar, you basically escape out a variable, and my name refers to the variable, not a string my name here. Okay, and that's gonna work the same way. Okay. Now, what does val do? Is that val creates image, which means that I cannot change the. This becomes like a final in Java or a const in C++. So my name equal to, if I try to set Rishabh's name here, this is going to give me an error that val cannot be reassigned. So that is what the val keyword does. We can move on to using var. Var stands for variable and val stands for value. Values don't change, variables change. So var my name equal to Arnav, and then I do my name equal to Rishabh, and now if I run this, you can see hello Rishabh is printed here, right? Let us try to set it to something else, which if any one of you has done JavaScript before, is something that you can do. You can actually change this my name to a integer. Let's try doing that here, and you will see you will get an error. The integer literal does not conform to the expected type. So here's something to be understood, that when we are creating a variable, setting it on the left hand side is not required inside Kotlin because it can infer the type from the right hand side. But Kotlin is not a typeless language. Like there are some languages which have very loose types, basically weakly typed languages, where you can change the type of a variable after reassigning it to a new kind of a value. JavaScript is a good example of that. Here in Kotlin you cannot do that because at the end of the day this code is going to run on top of the Java virtual machine and their types are important. So my name equal to 10 does not work here. Okay, now talking about setting the types, you can declare the types on the LHS of your argument as well. That you can do in this syntax. Like I said, it's a Pascal syntax. You use colon. The proper syntax is you should not use a space in front of my name, and then we write the name of the class here. Okay, so string. Okay. Automatically we don't need to import java.lang.string here because Kotlin code automatically imports the entire java.lang package. So anything that is inside java.lang is included here. So this way we can declare a particular type to a variable. Okay. Now we could also do is var my name equal to string and end this line here. By the way, if you had already noticed this, semicolons are optional. You can use them if you want to. You can omit them if you want to inside Kotlin. Not required here. Now var my name equal to string. If I do this, so here obviously I will get an error that my name must be initialized, right? And let's say we do initialize it. We write my name equal to Arnav in the next line, right? Now Kotlin makes sure that your variables are never null. So if you set var my name as string question mark here, so string question mark means that the value can be a string or the value could be null. Okay, so both these values are accepted. If it wasn't with a question mark, we would get an error here that you cannot set a null value to a variable that has type string. Now here is again a difference between Java. If you have a string variable, you can assign null to it. Now nulls are the bane of the software world. You can read up about nulls. It has been called the $1 billion mistake of the software industry, using nulls, the null reference. Now in the entire Java ecosystem, everybody knows that null pointer error is a massive problem. You have to always keep checking for null pointer errors. Now Kotlin comes in and says that okay, we can remove null pointer error by not allowing you to set null at all. Now when Kotlin is actually going to run at the runtime, there is no 100% safety against null pointer errors, because obviously some values that are coming from Java code might be null. So there is no 100% guarantee, but at the compile time you cannot set null to those variables which have a concrete type defined. If you want to set null, you will have to use a question mark like this. Okay. Okay, so let us now talk about some more functions here. Let's do some functional programming. So how functions work? I'm creating a new file, functions.kt. Okay, so let's consider this function fun area takes an integer side, say side is an integer. When you're using Kotlin, prefer to use int, not integer, int with a capital I. So this is a Kotlin class. Okay, this int is part of Kotlin. This is not the Java integer. Now this is a better wrapper on top of the primitive int instead of the entire integer class, which has a lot of other methods, toString and all of that stuff. So this is a fun area. And what does this function return? So my function is going to return the value also in terms of integer. So the return type of the function is defined after the function like this. Okay, and here I return this thing side star side. Okay, and let's do this println area of square of side 4 is area 4. Okay, this is a this side is not something that I typed. This is IntelliJ IDEA does this for you. It shows you the parameter names as a helper when you're running this. Okay, so let us run this. Now, how about function overloading? Let's say I want to create a area function that can calculate the area of squares as well as rectangles. So I can do it like this: side int say base height is also an int. Okay, so height, and I use a default variable here, height equal to something similar to languages like JavaScript, where a variable that has been used as a function parameter before can be used later on. Okay, now that's a very nice functionality that we have here. Do keep in mind that those variables that are on your right side, anything that is here, this you cannot use there. This thing is not possible, but the other way around is possible. Left side variables you can use it on the right hand side. Okay, so my return is going to be base into height. Okay, now let us do two things. Println area of rect 3 cross 4 is okay. We cannot use the function types here. Have to use a plus area 3 comma 4. If we run this, as you can see, when we pass base equal to 4, only one variable, that same variable was copied into height because I used height equal to base. Okay. When I pass explicitly two separate variables in this case, in the case of the first one, here I have two separate variables, height and base. So I get them separately here and here respectively. But when I use just one variable, so this becomes base, and since height is equal to base, so this gets copied here, and base and height both are 4 in this case. I hope that makes it clear. Now that is better than Java, because in Java, if you want to overload a function with two different function signatures, you will actually have to define two separate functions. Here you can use the same area function definition and overload it with one argument as well as two arguments. Okay. I guess this is clear till now to all of you, how function types are there. And let's say I have a function, one say hello, and this function say hello does basically nothing. Say does println hello. So we might be wondering that in case of this function, we were defining a type as int. This is similar as writing Java code, which is basically the Java equivalent of this would be something like this. We'll have to write some int and then your function. Right. So that you can write in Kotlin in terms of this area returns int. But what about say hello? This kind of function inside Java, this is basically your void type, right? This is the void type function. Now, the equivalent of void in Kotlin is we do not have void as a keyword here available. So instead, what happens is by default, this function returns unit. Okay. So unit is a primitive inside Kotlin, and this actually is very similar to void, because when something returns unit, it means it does not return anything. Now if you try to return a string here, you will get an error that there is a type mismatch. You are returning a string while this function was supposed to return a unit. Even if you don't write unit here, the same error you will get, because default functions return unit unless you specify them a return type. Okay. This say hello function, obviously we can call it here like this, say hello code. Okay. So that's how functions work here. Now let's quickly take a look at how classes work in Kotlin. You can directly define a class like this. If you create a class, and when you're creating this, if you do it with the kind class my class, okay, and a new my class type is defined. You can work on Kotlin the way you work on Java, basically always creating a top level class inside every function, every file. And when you're going to work with Android, we will actually stick to this kind of a convention, because it's going to help us, because some of our code is going to be in Java, some it in Kotlin, and so on and so forth. So there's this class. Now, even if you do have a top level class, you can still define functions like this. Okay, this still works. Okay, there's no problem with that. Now this class, my class, and where does the constructor of the class go? The constructor is inside the class definition. You create the constructor like this, okay, and you do val, say I create a different class name. Okay, I do class fruit name. Val name is going to be a string, and val origin is also going to be a string, and val weight is going to be an int. Okay, you can actually omit the body of the class if you want to. It is still a valid class, and we can create a how to create a new fruit. We create var f, type is fruit, okay, equal to, we call the fruit constructor and we call it directly like this. Okay, we do not have a new keyword in Kotlin. We simply call the fruit function. Okay, and inside the fruit function we need to pass these three things: name, origin, and weight. So let's say I give a mango from Lucknow, and which has a 1 kg of weight. Okay, how can we get this values available to us? We can println f dot name, that's available to us. Let's check that out. Okay, so that's how it works. What if I try to print f? So just like it happens inside Java, you get the object reference here. Okay, fruit at 27c, something like this. This is basically the memory reference of wherever this fruit variable is. Sometimes in Java, we create some classes which are only for holding some kind of data. If you are downloading data from the internet from an API, you create POJOs. POJOs are plain old Java objects, POJO, which stands for plain old Java objects. And what is special about POJOs? They have constructor and getters, sometimes setters. That's the only thing that POJOs have, and they extend from the object class, and they are not extended from some other class. They extend directly from object class. They have a constructor, they have getters. Okay, so these are simply data encapsulators. What we can do here is we can give this data keyword to a class and create a data class fruit. And now if I run this code, you see what gets printed here is a proper formatted values of the fruit. That happens because the toString method for data classes are already enabled, already configured. All the values that the data class has are configured, and you do it with this. Now this particular data class right now has values here, so you cannot change these data, but you could as well turn them into var if you want to. If you turn them to var, then you can change that data. F dot name equal to apple. Doing that is possible. Right, so that gives you a basic idea about how classes work. Now we're going to talk about something that might be a little confusing for people who are well versed with Java and not any other language, but we're going to talk about higher order functions. So What are higher order functions? Now, higher order functions are those functions that can take a function as an argument, or they return a function as an return type. Now, that is possible only in those languages which treat functions like first class citizens. Java does not treat functions like first class citizens because Java has actually the concept of methods. Now, methods are available inside a class only when you have a static function, or when you create an object of object of a class, then only you can call the functions. But Kotlin gives you first class status to functions because we can write our code entirely in functions without using classes. Now that means we can do quite a few things. First of them is you can create fun, my fun. Um, okay, and then inside this function we can define another function, my inner fun. Okay, and what that means is, let's say you have a variable here var x equal to 10, and you can do x plus plus here, and then you can call my inner fun from here, and then we can return the value of x. Let us give it int type. Okay, so inside our main, so let's print whatever has returned from my fun, and we'll be seeing that got 11 returned because this x inside this inner function you were able to access. So any variable inside an outer function is available inside an inner function, so you can create functions within functions. Um, you can create a function create greeter, which takes a person string. What it returns is a function that returns string. What the syntax means is, the type of my function is it returns a function which returns a string. So that means I will have to create a function here which itself returns a string, and then I can return greeter. Okay. Here I need to return some kind of a string. Okay. Now, when you do this return greeter, what it basically does is it actually calls this function. Now, this and this are no different because functions which do not have an argument can be called without the brackets. What we want to do is we want to return this function from here. If you want to return a function from here, you need to use this syntax. Double in front of a function means we are passing the function as an argument. Now we can do this. Create greeter, enough, and call this function. Okay. So this create greeter returns a function, and we call that function. Okay. Let's say this function takes something called a salutation, which is a string. So what I do is I do salutation person. Okay. I need to define that the function that is going to return also takes a string. I need to change the signature here. Now when I call create greeter person Arnav, and here I give the value hello. Now let's break this down, and first of all let's just run this and see what happens. Sorry, I did not print that. You see hello Arnav is printed here. Now let's break down what actually happened here. What happened here is, first I called create greeter here. Okay, we called create greeter, which basically ran this function, and I sent an argument Arnav, which was available inside person. When we run this function, a new function gets defined, which takes a parameter salutation, and I return this function. Okay, so I return this function. Now this part from here to here, this thing is my greeter function. Okay, that can be called like this using brackets. Okay, so this function greeter, this takes a salutation string. Where is this coming from? This is coming from hello. Okay, which means that when I return salutation person, it is taking the value of person from here, which in turn was taken from here. It's taking the value of salutation from here, which in turn was taking it from. Okay. This way we can use higher order functions, passing functions into functions or returning functions from functions. Any variable that was available to this create greeter function is also going to be available to the greeter function. This is a property in functional programming languages known as closures. Okay. Closure means that a function, if it is defined inside another function, is going to inherit the scope of the parent function. Any variables that were present in the parent function. Okay. So I guess the basics of this thing. I think that the basics about Kotlin should have been clear to you. Otherwise, is kotlinlang.org. Very good website by the people who have created Kotlin. Has got documentation about everything. So you can read about more on Kotlin from there. We had just really scratched the surface here on Kotlin as such. But these are the things that we will require for the next part of our webinar, when we are going to take an Android app coded in Java and we're going to convert it to Kotlin. So we'll require all of these things that we just saw in action right now. Right. So now I'm going to move to our Android project, and we're going to take a look at what this Android project does, and then we're going to basically convert that slowly piece by piece into Kotlin and see that we're going to reduce a lot of code and we're going to write really nice code out there. Okay. Okay. So what we have here is so this. So I had given you guys a project to check up on. Now this project was available to you on this website here. Code archives slash Android sample retrofit REST API, and I basically asked you guys to look at the Java branch. Inside the Java branch, you will see there are 8 commits. Okay. So these 8 commits I'm going to refer to as step 0 to 7, because that is how they are tagged. Each of these are tagged as step 0 to 7. This is initial project setup, which means just your hello world activity that gets created when you create a new activity inside Android Studio, and then going forward the steps that are there. How does this app look like at the end is let me just show you the app in action. Okay. Yeah. So this app that we saw, it was basically showing these things: the albums, the users, the to dos, and all of this stuff. So all of that stuff is coming from this website called jsonplaceholder.tippycode.com, and inside this, what we have here is some example REST APIs. There is a posts API, users API, to-dos API, and a albums API. These are the 4 ones that I've used in my app. This is just a lot of JSON data. Okay, all of these are JSON data, right? So we have taken data from this API and we have shown it inside the app. Let me quickly go through the steps of what I have done to achieve that. So the I just have this plain main activity default stuff that is generated by Android. Um, inside activity main, I have just, so we are not going to use constraint layout anywhere in our app. Okay, by default, when you create apps on Android Studio 2.2 and above, the default layout that gets set is constraint layout. So you're not using constraint layouts. We are going to stick to the traditional layouts, linear, relative layout, and frame layout, only these, right? Okay. Now, the first thing that I have done is, so I've added a lot of new activities. So I have created album activity, comments activity, photos activity. All of these activities are empty stubs right now. Nothing inside this. So I'm just going to go through all of these commits. You can correlate them with the GitHub repository. These are the 8 commits that I'm talking about when I'm basically checking out step 0 to 7. Okay. So um, there are the activities inside main activity. Still, there are no changes here. First, I set up the activity stubs. Then the next step, what I have done is, inside main activity, we have added some stuff. We have turned the main activity to look like this. Created 4 image buttons and put these images: a user image, a posts image, a album image, and a to-dos image. And in our main activity.java, I have created a on-click listener, and this on-click listener listens for each of these buttons. I have set up on-click listeners for each of these buttons, and I'm basically going to each of these activities. I hope everybody is able to follow through with the code that I'm showing here, because the basic Android part, I'm not just going to write down the code because it's going to waste us a lot of time. So creating activities, creating recycler views inside them. Just in case some of you don't know what recycler views are, they are similar to list views, just that the performance is better in recycler views. It's a support library available. Similar to list views, you need an adapter with them. So creating the recycler views, creating the adapters, and getting the data using retrofit. This part I will just check out each of these commits and show you how they are. Okay. Um, the next step that we have done is this. Mm, So step 2, the app is basically just like this. Click on any one of them. We are opening empty activities inside each activity. Just this stage, right? Let's go to the next step. We have added some list item views. The list item views are here in this folder. Your res layout. The font might be a little small. I'll just increase the font size. So here we go. Inside layout, I've created a list item for the albums. The album list item is just simply post list item. Okay. So what these items look like, this is the post list item, this is the album list item, which is just the album title, this is the to do list item, has a box and a task name, and there is the user list item, which is like this, name, username, email, and phone number. Okay, these four list views have been added. The activities, album activity, and all these are still just like they were in this commit, the step 3, which is the fourth commit. Then let's move on to the next step. Here what I've done is I have added models for each type, because when the data that we're going to get, we need to create Java objects for that. So I've created a album model which has ID, user ID, and string title. These models are all mapped as per the API. So my API, as they are like the albums API, we can see that it has user ID, ID, title, which is a string like that. So on, if you look at to-dos, to-dos have user ID, ID, title, and completed, right? So the same properties, we have done this. There is an album model, there is a post model which has user ID, ID, title, body, to-do model which has ID, user ID, title, and a boolean completed value, and then there is a user object which has ID, name, username, email, and phone. Now the JSON placeholder API for user sends a lot of data. We are just dealing with only this part, the name, username, email, and phone. So we have added the models. Then the next step we'll do is we create the adapters. Now adapters are like this. So there's the album adapter. These are all recycler view adapters. Okay, recycler view adapters, they extend recycler view adapter and they have a view holder inside them. So inside album adapter, we have defined some stuff like this thing. This is the layout that we are going to use inside the album list items, and inside on bind view holder, so we have done TV album title, and we have set text, this thing album.get title, and we call this bind view function inside our on bind view holder. Now how does a recycler view work roughly, just in case you people don't know, is that it's going to be somewhat like this. You have your phone screen like this, okay, and there are going to be a lot of items which are coming on your phone screen, like there is item 1, then there is item 2, there is item 3, and say your phone can accommodate only up to 4 items on the first screen, and then there is the list continues below, and there is list upward as well. You can scroll upwards or you can scroll downwards. Now Android creates only 4 views for you. Now when you scroll up, when we go upwards, so when the next item needs to come into the screen here, at that time this item also goes out of the screen. So what Android will do is it will take this view element, okay, this view element, it will take it and it will recycle it back here. Okay, so the same view object gets recycled back to the bottom of your phone, and only the data is changed inside it. So the task of inflating it from is not going to be repeated again. The inflated item is going to be just reused in another position. Okay, now how does this work is, for the first time when these 4 views are created for the first time, when you're basically laying out a new list of items, all of them make a call to the on create view holder function. Okay, and whenever an already existing view basically gets recycled back from the top to the bottom, or when you're scrolling upwards, it will happen exactly the same. From the bottom to the top, something will get recycled back. Okay, so when this recycling happens, a view that was taken away from a position and given to a new position, on bind view holder gets called. Okay, so the arguments also are going to make sense. You will see that on create view holder, we need to create the view holder. We don't get the position here because the position does not matter here at this point of time. The position matters when you are actually binding the view holder. When you're binding the view holder, you show the data. So we take the album on this particular position, albums.get position. Albums is an array list. Okay, albums is an array list. We get the album of that particular position and we pass that album to the bind view function. The bind view function does the work of tv album title dot set text. Okay, so every time a new view enters into your screen, whether it was an old view or it was newly created, on bind view holder gets called, and when on bind view holder gets called, the data is shown on your screen. Okay, that's how this thing works. Then we have post adapter. Post adapter also has a private array list of posts. While we are constructing it, we take an array list of posts. On create view holder, we create the layout. On bind view holder, we call the bind view function, and inside the bind view function, we set inside post title, we set the title. Inside body, we set the body. These things, TV post title is what? TV post title is basically my ID inside the XML file. So I have taken that, find view by ID, put them into TV post body. Okay. I am using the exact same name for the variable as well as for the ID inside XML. It's a good practice. You should also do it when you are working on Android. You can keep a track which ID is which view. You can keep a track if you use the same ID name and the same variable name. Although you can use it differently because it's not compulsory to use the same one. Okay, and similarly we have other adapters. We have a to do adapter, we have a user adapter. Okay, so adapters are here, and now the adapters are here. Next step, what we do is we create the retrofit functionality. So we create a API package. Inside API package, we create first of all an interface called JSON placeholder. Okay. And this is basically how retrofit is supposed to be used. Retrofit, if you look at the documentation on the retrofit side, we create an interface like this. So a get request to the users returns an array list of users. A get request to posts returns an array list of posts. Get request to album returns an array list of album, and so on. We have these functions. I have created a singleton called client. What is a singleton? A singleton means that I can create only and only a single instance of this class client. How do I ensure that? My constructor is private. Okay, so if your constructor is private, no external class can call this new client from outside this code. We have a instance of this client class itself called our instance. Okay, and we do private static final client. Our instance is new client, and this is the only instance that we create, and we are never going to create any more instances. And whenever somebody calls get instance, we just return our instance. So during the entire life cycle of our app, there is going to be forever just this one client instance. Okay, inside this client instance, we have a retrofit object. A retrofit object is built like this: new retrofit.builder base URL. This creates the base URL so that when you write get users, this users value is actually appended to JSON placeholder.typicode.com. Okay, then add converter factory. I have used a JSON converter factory. JSON is a library created by Google to easily convert JSON data to Java classes, to and fro, both ways. JSON objects can be converted to Java objects, and Java objects can be converted to JSON objects. So we are using a JSON converter, which is one of the most popularly used converters for retrofit. So this means that every request of mine will, if an array of JSON objects come, they will get converted to an array of Java objects for me, based on the particular model class that I use. If I have specified an array list of to-dos and I send a request to albums, then it will try to convert album JSON objects to to-do Java objects. That won't work. So we'll have to set that in the correct way. And there is an instance of this JSON placeholder API, the implementation of this interface, that is created using retrofit.create. Okay, this creates our API, and now we need to basically call this API. So do that. Okay, now we have written our code to call this data and work. How that works: inside, say, albums activity, inside album activity, what are the things I have done? First of all, I have taken access to the recycler view. The recycler view is inside my layout. Okay, there's a recycler view inside activity albums. Taken access to that. Then I have created a new albums adapter. How is that albums adapter created? A new album adapter, and inside a new album adapter, I have sent a empty array. Then I have set a layout manager. I'm using simply a linear layout manager for my recycler view because it's going to just look like a list. I'm not using something like a grid or anything. I have set the adapter. And then we do this thing, client dot get instance. This gets me my instance of client dot get API. This gives me an implementation of JSON placeholder API. Get albums, which means that this function get albums, and I use the enqueue method. Retrofit has enqueue and execute methods. Execute methods work synchronously, that is on the same thread. Enqueue methods work asynchronously, that is on the other thread. Now, because this is an activity, album activity, it's activity UI level code, I don't want to call execute, I want to call enqueue. I call enqueue, a new callback is created for me, and inside that callback, I get a response. Response.body is basically my array list of albums. So I do album adapter dot set albums. Okay, and inside the set album call, I call notify dataset changed. Now, at this point of time, let us just run this app once. Okay, this is till now just pure Java code, and this you can see on basically when you go to a browser and you go to this URL. Okay, so this code that you can browse here, this is basically at step 7 till now what we have discussed. Now we're going to start writing our Kotlin code, start converting this to Kotlin. Let us first take a look at this. Let's run this and see whether it is working the way we intended to work. Okay. So let us see inside users, we're getting the list of users. Posts, we're getting list of posts. Albums are also coming, and to-do lists are also coming. Okay, so let us now start converting this code into Kotlin. Okay. So we're going to start with the best place to start writing Kotlin code is to convert our models. Okay, now our models have pojos. These all classes, sorry, um, our models. These all can be converted to a single line of Kotlin code, right? So to convert stuff to Kotlin, let us start with this thing is select this particular file, and inside Studio in the code tab we have convert Java file to Kotlin file. Let's just run this for a second. When you do that, it gives you a warning that the conversion might not be 100% accurate. See, generally the conversion just converts into a single line of code. It's been done. Uh, if you file close and open it, you will see it gives you an error, Kotlin not configured. So we need to configure Kotlin to use because by default when our Android Studio project is created, it is not configured to use Kotlin, because when you want to run Kotlin code inside Android, you need to also install some libraries, the Kotlin Android runtime basically. Okay, the Kotlin Android runtime makes it possible for Kotlin bytecode to run on top of the Android runtime, because the Android runtime is not exactly the Java virtual machine, it's a different virtual machine. So we click on configure, you will get this dialog box. We're going to select the latest version of the Kotlin compiler and runtime that we get. Okay. So when we do that, a couple of things happen. What are they? Your Gradle files, two of your Gradle files, the project Gradle files gets this line added to it. Okay. This line also gets added. This is the Kotlin Gradle plugin so that Kotlin can be compiled. And inside your apps folder, you will see that this line gets added. org JetBrains Kotlin stdlib.jre7 Kotlin version. This Kotlin version we are picking it from the main file so that the Kotlin version is same across everywhere. It also adds this line repositories Maven Central. This, if you want to, you can remove these lines because by default we are using JCenter as repositories. JCenter covers everything that Maven Central has. Okay, so Kotlin has been. Let's do a Gradle sync. Right. Um, Now, what I'm going to do is this works. Let us do is take all of these three, and we just convert them to Kotlin. Okay. So we have converted all of our models to thing mm, Kotlin code. Now, since they are just one line of code, why do we need to put them in separate files? We don't need to. Let us create a new Kotlin file. Okay, and this Kotlin file is called models.kt, and inside this models.kt, let us move all of our definitions, because in Kotlin you can define more than one class at the top level inside your files. These classes, where are they going to be defined? Inside this package. Okay, if you don't write the package name, it's going to be created as bare classes with package list. That does not work with Android because Android requires packages. So all of these are going to be created inside com.codingblocks.restapi.models. Okay, let's start moving them one by one. We move this user. We turn all of them to data classes because these are POJOs. That's the purpose of them. Okay, turn all of them to data classes, and let's select these and delete these files. So now we have reduced our models to models.kt. Okay, so I'm going to commit these files so that after the webinar ends you can check out these commits specifically. So use Kotlin for the models. Okay, so next up, what we are going to do is we will start taking a look at these adapters. Now these adapters are another place where using Kotlin can reduce a lot of code that we are writing. Okay, so to start with the adapters, let us first of all just select all these adapters, and we are going to just select convert Java file. Okay, so here is an important thing, just take a look. Okay, these Kotlin converted files, they are not correct right now. When you convert code to Kotlin using Android Studio, all of the time the code is not exactly correct. Sometimes it's wrong, because right now you can see the code is actually wrong. Okay, we are going to fix that, but what I'm going to do is I'm creating a commit at this stage, so that when you actually look at the code, you will see that what the automatic conversion creates for you, and then you can look at what are the things that we fixed to make it work. Okay, so I'm going to create a commit automatic conversion. Okay, right. So what are the things that are problematic here is, now we have a problem here is that recycler view dot adapter uses albums adapter dot album view holder as its type. Now this is an internal function. Now internal functions cannot be exposed as types outside, because internal functions are only supposed to be used inside this class. How can we change that? we just simply change it with inner class. Okay, we don't write internal here. Now that is what the internal modifier does. Now if your class is internal in nature, then you can only use the class within your external class. Now we were actually using this class album view holder to define the type of our external class itself. That would create you a circular dependency, because this class should not be available when you are defining this class. This class should be available only inside this class. So this internal we need to remove. So we're going to do that everywhere. We'll need to remove this internal from everywhere. Okay, all the adapters would have been set as internal automatically, because inside Java, when you have a private, basically a package private class which is dynamic in nature within an outer class, Kotlin converter will automatically convert it to an internal inner class. What you need is just an inner class, not an internal inner class. Okay, now that's done. And now when that's done, at this level your app will actually compile and it will work, but this is still a lot of code here right now. Okay, so I'm just going to click on run, and we're just going to see whether this runs or not before we proceed further. And while I wait for that, let me cover a couple of things that were asked in the live chat during this time. So very right in the initially we okay, someone asked how to increase the font size, share the shortcut keys. There are no shortcut keys, Varun. You have to manually set them. Go to preferences, keyboard shortcuts. You can create your own keyboard shortcuts for that. Control plus plus does not work on Mac and Linux. That aside, people had asked that whether Kotlin would have long-term support for Android or not. Kotlin will have long-term support for Android because Google has thrown their weight behind it now. In fact, the way I look at it personally, I think it is going to be like the Objective-C and Swift ecosystem that Apple has for iPhone development and Mac development. So originally all the code used to be in Objective-C, and a new language was developed, Swift. Swift can compile to the same native runtime on which Objective-C code runs, and now most of the people are writing their code in Swift because it is functional. You have null safety, you have got type inference, you have got functional programming. The exact same thing has happened with Kotlin here. Writing code in Java means you have to write a lot of code, and sometimes that helps. Sometimes that helps, that extra verbosity makes your code much more readable, but sometimes you just want to write a lot less code and get your app running. Kotlin helps you achieve that. Since the design of Kotlin is that Kotlin compiles to Java bytecode, and when you are actually running on Android, the same time also the same thing happens. First of all, the Java C, which is the Java compiler, runs, converts your Java files to Java bytecode, and then that Java bytecode is converted to your Dalvik executable, right? So Kotlin becomes Java bytecode, and from that point forward, your Kotlin code and your Java code go through the same passage. They get converted from bytecode to Dalvik executable, and they go onto your device. So until and unless Google actually changes the Java bytecode format, which is a really tough thing to do for them, they will have to create their own Java compiler, which I don't think they're going to do for the next 4 or 5 years. So if unless they do that, till then Kotlin is a very safe bet. And although Kotlin was actually announced at Google I/O just this year, people have been using Kotlin to write apps for more than 2 years now. So I think I saw the first Kotlin talk by Jake Walton, I think in 2015. So it's been 2 years. People are writing apps in Kotlin, and in fact, the Google announcement changed nothing. There was support inside Studio for Kotlin, and there was gradual support for Kotlin for at least more than a year already. So you could write Kotlin apps even before Google announced it. Google announcement just makes it even better, because Google has said that they will work with JetBrains together and make Kotlin more and more usable on Android. We're going to use some of those extra usability functions that Android has, Kotlin has on Android right now. Okay, coming back to our app, let's see if my build worked or not. So things are working. It's exactly in the state that it was earlier. Okay, pretty good. Now, how can we reduce this code even more? First of all, let me just commit this part as well. So I'm going to create a new commit. The code that I'm writing right now, you can actually, I'm pushing it also live, so you can check that out directly if you want to at this point of time using the same repository on the convert to Kotlin branch. There would be a convert to Kotlin branch here. So there is a convert to Kotlin branch here. This is the one we are coding on coding right now, so you can always check that out whenever you want to. Okay. Now let's start reducing the code a bit. Before we reduce code a bit, let us talk about some other problems also we have. This operator here, double exclamation mark, this stands for a not null operator. Now, what does this operator mean is that this operator is there to create null pointer exceptions, which is folder.bindView in its argument takes an album. It does not take a null album. Okay, so this, it would have allowed nulls inside that, but it's not there, so it's going to only accept proper album types. When you're calling bind view albums position, now this is the same as doing get position. This is like in Java you do albums.get and you do position. In Kotlin, array list also can be used with the square bracket notation. It's an operator overload. Okay, it's actually an array list. It's not a static array. It's a dynamic array, just like array lists are. But you can use the square bracket notation. But what if albums was null? So in that case, albums position would also be null. So that does not happen, we have a not null operator. Now this only helps us compile. I mean, we could just write this and then you would get an error here. So that you don't get an error here, we write this. But this means I am just deferring that error from compile time to runtime. When we are running this, if albums is actually null, we will have a problem. Okay. Similarly, the same thing for this code. So these problems also we need to fix when we go forward. Other than that, one thing that Kotlin can do very nicely is not having to call find view by ID. Now this we can change using Kotlin and extensions. So what we'll do is inside app module, we will apply another plugin. Kotlin Android extensions. It's sync or gradle. What does Kotlin extensions, Android extensions provide us with is, we have this concept of synthetic classes. What are synthetic classes? Let's take a look at synthetic classes. We can import kotlinx.android.synthetic.main, which is because our the name of our module is main. Okay, because our code is inside src main. Okay, synthetic.main dot, and this particular view that we are going to deal with here in albums is list item album dot star. Okay, what is the synthetic thing we are talking about? If you actually extend this more, you will see that there is a view inside this, and inside that view there is TV album title. Where is TV album title? TV album title does not actually exist. It is actually from the XML file. Okay, what Kotlin Android extension does is, before we understand that, we need to understand how XML files work in Android. Now, how XML files work in Android is these XML files are available inside your APK in a compressed form as XML files. They do not get converted to Java code. Okay. So when you call something like set content view, or you call something like layout inflator dot inflate, these files are read line by line from top to bottom by the Java runtime. So it's a slow process that happens. It reads and it creates new view items for every view that is present inside the XML. For example, if you talk about this particular resource file that we are working with, list item album, Android is going to read it top to bottom. It will first create a card view object, and then it will create a linear layout object inside that using the add view function, and then inside that we create a text view object. Okay, this is going to happen in runtime. Now, what synthetic Kotlin synthetic classes are? It creates a class for you during the compile time. Now, this class does not actually exist. That's why it's called a synthetic class. And this class is basically like a static class with some static variables which point to the same IDs that your XML file has. Now, the idea behind it is we don't need to call find view by ID, because what exactly is r.id.list item album, r.layout.list item album? What is it? If you go to your project view, inside that you will see there is a app folder, there is a build folder, there is generated stuff, there is res, there is r, and inside r you will see that your package name, and there is a r class, r.java class. Now each such item, list item or whatever it was, they are all actually integers. Okay, so r.anim.abc fade in is actually an integer. Okay, so Kotlin creates a synthetic class and it creates the same variables pointing to those same integers for you temporarily during the compile time, so that you don't need to use find view by ID. How is that going to help us? Let's check out. Here, let us change this code a little bit. In this class, album view holder, item view, recycler view, item view, what we do is we have a var tv album title, and we have an init. Init is basically anything that you need to initialize inside this class, and we do that using item view dot find view by ID, r.id dot tv album title as text. Now typecasting happens like this inside Kotlin. Okay, let's do is remove all that stuff. So where will we get TV album title from? Here's the funny part. We create some default arguments. TV, we do like this. Item view dot TV album title. And you see that this works actually. Why? Because item view is going to be r.layout.list item album, and inside item view, TV album title as an ID can be picked up using Kotlin synthetic classes. Okay, so whenever you inflate or you do set content view, and that runs you a view, inside that view, basically this list item album, inside that view, if there are any IDs, Kotlin allows you to access them directly using the dot notation. Okay, now although TV album title does not directly exist inside item view, when we do TV item view dot TV album title, it basically returns a reference to that ID, which is actually an integer in Java. Now we change this. Also, we can reduce this line of code a little bit here. We can do is of writing this here. So layout inflator dot from parent dot context dot inflate. This is the view that we need to pass into the album view holder. The get item count, now here we need to fix this. Here we're going to use an operator which is going to be like this. So we are going to do albums question mark dot size. So this operator returns an integer. If album exists and size exists, it returns an integer. If album does not exist, or if the size inside the album parameter does not exist, in both the cases it is going to return null. So it's a way to ensure null safety. Now if this entire value is null, we can use the Elvis operator, which is like this, question mark colon. So if the LHS of the Elvis operator is null, the RHS is used. The RHS is 0. So when albums is null, we return 0. Okay. Here we do the same thing. Inside bind view, we have this not null operator. Let us do this on a question mark. We can just call it simply like this, and album dot title. So we do album question mark dot title. Okay. Now we will set null as the text if we get it. Now let us make similar changes elsewhere. Let's do it for the post wrapper as well. Inside post wrapper, what will happen is we will move this line. Okay, and then we'll change this similarly to question mark dot size 0 using Elvis safety operators. We will remove any variables that we had here. The init function we don't need. We are simply going to do item view dot tv post title. We're going to do item view dot post body. You need to always import the synthetic classes like this if you want to use these tv post title, tv post body IDs directly here. Okay. There's a little bit of problem with this boolean. To do dot is completed. The value is should be completed, not is completed, because otherwise the JSON won't be able to convert it properly. Okay, so Kotlin might make some mistakes like this when converting. Should take a look out for that. Okay. And finally we want to do it for the user adapter as well. So inside the user adapter, You can see a lot of code gets reduced already. Okay, so our adapters are now changed into Kotlin and the code has reduced a lot. So our adapters are in Kotlin. Right. Next, what we're gonna do is we're gonna take the activities and convert them to Kotlin as well. And when we convert activities to Kotlin, we can again take use of synthetic views, and that will reduce the code that we're going to write. So let's do this. Users activity, to-dos activity, post activity, and albums activity. These are the activities that we had created. The other two just empty for now. So we convert that to Kotlin. Now here again you will see that there are some problems with the default generated code. So I'm again committing that. This auto generated activity in Kotlin. We will now fix them. Now how do we fix that stuff? We don't need this RV album list now anymore because we can get just delete this. Okay, delete that. RV album list becomes red because this variable does not exist. No problem, just alt enter and import. You will see the synthetic activity albums has been imported and RV album list is available to you. Okay, except that it's now we have the album adapter as well. Now adapter, since we are only using inside the onCreate function, what we can do is let's just remove this line here and do var albums adapter equal to this. Okay. And this line also we need to remove because find view by ID we don't need anymore, because our v albums list is actually the view object itself. Okay, and album adapter is album adapter like this, and since the value is never going to be changed, it automatically tells me that we can change it to val here. Okay, so here's the code that the changed code looks like. We're going to call set content view. We create an album adapter. We don't set a type because it's going to take it from the right side, array list of album. We set the layout manager. We don't need to, by the way, in Java, whenever there is a function like set a layout manager like this in types of set x or get x, those can directly be called by putting them on the LHS of the equal to symbol. Kotlin is going to handle that at the compile time. When it is going to compile, it will convert it into a set layout manager call, and similarly this will get converted to a set adapter call. Okay, you can simply do dot adapter equal to albums adapter, even if there is no real object called adapter inside RV album list. Sometimes that happens. Actually, the name of the variable inside a recycler view, if you look at the code of recycler view in Android source, is called m adapter. The actual variable is not adapter, but because the setter and the getter are named as set adapter and get adapter, the variable you can just simply omit the set and get and simply use it on LHS of the equal to for set and RHS of the equal to for get. Okay, do that stuff, and then here you see a new kind of a syntax, object callback. This syntax happens because callback is an interface, and interfaces cannot have objects actually. Okay, so you create an object with the type of this interface like this. you cannot call a constructor because the interface does not have a constructor, and the only way to create objects is by calling a constructor inside Java and in Kotlin. So since you can't do that, and there is no new keyword, okay, in Java we implement an interface using new, and we also create object of a class using new. So the new keyword does these things for you. In Kotlin, new does not exist. So you create an object with the class callback, and inside the body you override the functions, one on response, one on failure, and all of that stuff, right? Okay, let's get ahead and see what else we are going to do. First, let us do this for all the activities. We'll need to do the same thing for post activity. We need to delete these lines. Val post adapter equal to this rv post list. Just remove this and we import it. Okay, looks good. To do's activity, same stuff. Remove the internal variables. Turn to do's adapter as an internal val and remove the find view by id call. Then rv to do list as a synthetic parameter. Users activity, again same stuff. Delete these lines. Remove this line. Val user adapter and rv user list can be imported like that. Okay. So that looks good. Let us again try to run this app and see if it works at this point of state. I will just create a commit on this. So if you have any questions till now, anybody can just ask them if you were not able to understand anything that was explained till now. Okay, so Sajal asked that why we removed internal from the adapter is because if you create something as internal, that class can only be used inside its parents class. Now, if you look at the adapter code again, I'll just open that up. So this album view holder, this class was also used to define our adapter itself. This part of the code, this place in the code, okay, this is not outside the class. This is part of the definition of the class itself. So we are using an internal class to define an external class. And that is a dependency that cannot be afforded. So we have to make it not an internal class, okay, because internal classes can only be used inside this class. Basically that means that you can only use it in a dynamic area, in basically inside an on create function or somewhere like that. Okay, so let's see how this works. Users are working, posts are working. album is working and to-do lists are also working. Okay, so same app is working the same way, everything is fine till now. We have not converted the main thing yet. We have not converted our main activity. Okay, let's take a look at our main activity. First we'll convert the main activity, and then we're going to do a really nice thing. We're going to reduce use lambda functions, and using lambda functions we will reduce the part of the code where we are using enqueue, and then we will use an object to create a singleton. So let us look at all these three things. Main activity, let's convert this to Kotlin. Okay, you can see that the code has reduced a lot and you see quite a lot of new syntax. First of all, these internal variables not needed. These find view by id calls not needed. These we will get from synthetic imports. Okay, more lines reduced. Now here is how a switch case works. Switch, instead of switch we have when. So inside view.onClickListener we have when. Inside when view.id, and the view.id value is r.id.buttonAlbums. We do I equal to this thing. When r.id.buttonPost, I equal to this. r.id.buttonToDos, I equal to this. When you're using this, you need to write @, and this is because this is the same syntax that Java uses. Because if we write only this, it would refer to the onClickListener. Okay. If you want to use the instance of main activity inside which you are there, in Java you write this same code in this format, main activity dot this. Okay, in Kotlin the same thing is written as this @main activity. Okay, this @ syntax also is available in Kotlin for a different purpose as well. I'll just take a quick detour and just explain it to you. If you have a function A, and inside that you have a function B, inside that you have a function C, and say inside that we have some for loop going on, and here if we want to return, by default which function gets returned? Only C gets returned. If you look at any other kind of programming language, C gets returned. You could do return at B or return at A like this if you want to return the outside function as well. Okay, so this is called basically which functions call site are you referring to, that you can define like this. The same way this also works in the same way. You use the @ operator at main activity, that we are using this instance of the main activity. Another new syntax type you will see, that when you are using the Java class, because Kotlin does not enforce classes, anything that you import inside Kotlin need not be actually a class. If you want to refer to its Java class, you need to use this syntax: class name :class.java. If you just use class, this is the Kotlin class. Okay, the Kotlin class is not the same as the Java class. Kotlin classes are slightly different. So for Java classes, you need to do dot. Okay, so this way you create a new intent: main activity dot this, album activity dot class. The way we do in Java, here we do it like this. So we have set our on-click listeners, and our activity code is also pretty minified. Let us commit that. Right. Now we'll talk about what lambda functions are. Now this is an example of where you can see a lambda function in work. As you can see here, that this val on button click listener, view dot on click listener, inside that you actually implement what you do is you create override the on click function. On click function takes a view inside that, and it works like this. Now how do lambda functions work? Let us take a look at this thing. our Kotlin code again, and I will show you a lambda function, and you get a better explanation of how this lambda function works. Let me just give you a overview of what lambda functions are. It's about functional programming. So lambda function is like you have the lambda symbol, right? In mathematics, you have the lambda symbol. I'm just say calling that as I will call that lambda as f. So if you can represent the return type of a function like this, y is equal to f of x. This is called a function, just like you know in mathematics. Now, if you can represent your entire program in terms of fx, then that is called functional programming. Now, fx need not be just single variable. It could be f of x comma z. It could be a function of two variables. Okay. So, y, let's say fx is this f function. What this function does is it returns t square. Okay, so y equal to fx, if we write like this, that is basically writing f is equal to x square. So writing these kind of functions, we basically do it like this: x as the argument. We usually use arrow, either this or this, depending on language. JavaScript uses fat arrows, Java uses thin arrows. Arrow, and in front of arrow you write what would be the return, x. Now, if you have a function that calculates areas, similarly like that, you have area like this, a comma b, and that returns a into b. You can return, instead write it in this form: area equal to function of a comma b returns a star b. So this is what lambda functions are, and this kind of a notation is called the lambda notation. So if you know what a function takes as an argument, and if you can represent directly the return type, or if you want to show the body, you can show the body here. Okay, so expressions are lambda expressions. Coming back to our code, you can see that view.objectListener takes a function as an argument. What is that function? It is onClick. What does onClick take as an argument? View. So we run view arrow. In front of the arrow, we write the body of what is going to happen when we do onClick. Okay. So this is the way lambda functions work. Let us take a more uh, contrived example so that you would be able to understand it even better. Okay. What we'll do is take a similar approach. Okay, take a similar approach to this create greeter kind of a thing. Okay, and let's say we create this function called fun say hello. This say hello takes a function as an argument. Now to write the function type, we define it like this. What does this line basically mean? Say hello returns string. Say hello takes an argument fn. What is fn? Fn is a function that returns a string. Okay, we do that and then we write here return hello plus we call fn, right? Then we create a function like this fun create greeting. This create greeting function also takes a function. Now this is a different kind of function. This function takes a string as an argument and returns a string. I'm also using a second argument. Okay, this entire thing is one argument plus its type. Second thing is a name, which is a string. Okay, and this function also returns string. How do we work here is we return, okay, hello, and then we do is plus now we got this name here as an argument to create greeting function, right? And inside create greeting function we got another argument, that is this function. So we take one of our arguments name and we pass it into the other function fn. This is what we have done, and this function will return us a string. That is what we assume. Now we don't have an fn defined to us yet, so what we do is let's just create a main function and try to call this function. How will that work is we'll do println create greeting. Now create greeting takes first argument is a function and the second argument is a string. Let's write the second argument first. Okay, so let's say the second argument is Gupta. What is going to be my first argument? My first argument is going to be something of this type. It's going to be a function, and it has to be a function that takes a string argument and it returns a string. So I create braces to create a function body, and I write s, which is the variable that I'm taking as an argument, and it returns s plus Arnav. Okay. So what does this syntax mean here? This syntax means I'm talking about a function inside which if you pass s, you get s plus Arnav. So inside this function, if you pass x, you will get x Arnav. If you pass t, you will get t Arnav, like that. Okay. So s returns s plus Arnav. That's what my syntax is here. If you want, you can reduce it to like this. Okay. S returns s Arnav, and I pass name as an argument, and I call create greeting. Can anybody guess what the output is going to be? So you got hello Gupta Arnav. Okay. Now how does this work? How does hello Gupta Arnav work? Let us just break that down again and let's just follow where this variable went. Okay. First, talking of this function from here to here, this is a function. What is this function going to be? This is the function that becomes my argument fn. Okay, this is the argument that I am sending. S is this string argument, and this return type is this string argument. Okay, and the second argument name is coming from my second parameter that I sent to create greeting, which is this. I send two parameters. One is this function, and secondly I send this name. Okay, they are available to me. In this form. Okay, now what happens when I run this function? I run this. First I write hello. Okay, first we get hello, and it's perfectly fine here. We get hello here. What comes next is fn name. When we do fn name, we run this function. We run this function. Where do we get name from? We get name from here. So this name comes here, then it goes into S. Okay, so we get Gupta because of that, and Arnav was hard coded in this string, so we get Arnav here. Okay, so this thing that we defined here, this is called using a lambda, because instead of sending a already defined function, we created a new one and immediately sent it as an argument. Okay, so I hope this is clear. If it is not, you should read up more about lambdas. It's a very interesting topic in computer science. Functional programming is a huge field, and we use lambda functions in a lot of places. If you do mathematical programming like R or MATLAB or anything like that, or Python for that matter, functional programming is used a lot in all of these places. Let's get back to what we were doing. And we were trying to see if the app worked in this state. It did work. Let us see where we can reduce a little bit more of code. Okay, this client, we can reduce this code. How? We can create it as an object. Okay, how we can create it as an object? We can do, let's just convert it to, first of all, Kotlin. Code convert Java to Kotlin. Okay, so class client private constructor, we have a companion object val instance equal to client, all of that stuff. We don't need all of that stuff. We just need is object client, remove this stuff. Object client has val retrofit, has val API. It does not need a companion object inside it. Okay, simple stuff. Defined only once, you cannot redefine it. How do we get access to this in our adapter activities? Let's see. Client dot simply API, client dot API dot albums. Everywhere else also client dot API dot posts, client dot API dot to dos, and client dot API dot. Okay. So now much less code. Your client.kt is an object client, has val retrofit and has val API. This way you can reduce singleton directly to an object. This does not have a class. Okay, so using this from Java would be a little bit of a problem. It's outside the scope of this discussion how we can use this in Java if we want to, because right now we are just using everywhere in Kotlin only. Move single singleton to a class. Sorry, singleton to an object. Okay. Now let's talk about Kotlin. Now, because Kotlin does not have classes, we can create some bare utils outside. So we can create something like we create a package, say utils, very commonly used architecture that we do with Java is we create a utils package when we have to write random stuff. Okay. Inside that, let's create a Kotlin class. Let's call it helpers.kt. We'll create some Kotlin stuff here that is going to help us reduce some code somewhere else. Let's see how that works. Okay, what we're going to do here is now let's talk about this common piece of code that we have written in a lot of places. Client.api.album queue, and there is an object of callback like this. Okay, now we can reduce this code a little bit. How? Let's take a look. We can create a function which takes a generic type t, because we wanted to work with all the callback functions, and we call this function as they call it retro callback. Okay, now this retro callback function takes a function as an argument, and this function is of this type. It has a throwable. Okay, and let's look at the signature here. What happens is we get two things. We get a throwable and a call object when failure happens, and we get a response and a call object when a response takes place. Now this call we don't deal with, because this call contains data about the call that we made ourselves. It contains the request body, the request headers. We are generally dealing with the response. We are not dealing with the request here. Okay, so what we'll do here is we create this retro callback. Okay, or we call it something retrofit callback, RFCB. Okay, this RFCB takes a function as an argument, which itself takes a throwable and a response. Now this response is going to come from retrofit response type t, which is this type. Okay, that's the type that the response is of. This is the retrofit.response, which has type t. It takes these two variables, and from that it returns a unit. Now when I return a unit, it means that this function did not have a return type. Okay, it will just be a simple function, nothing to return. Okay. And my function itself, my function RFCB, returns an object of type callback, retrofit callback of this type t. Now just think about it once. If I call this function, I will get an object of callback t type. Isn't this exactly the object we require here? We require an object of callback t type inside this enqueue class. Okay, so we create that. and then we do our overrides here. We override, what we do is we return an object whose class is callback, which automatically means we will need to implement the members on failure and on response. What happens is you can if you just want to return something here, you can simply do equal to in Kotlin. So you can do is when failure happens, we call this fn function with null. We call this fn function with null and this t as throwable. Okay. T slash null, because the first argument here is throwable. Okay. And we need to make response also optional in nature here, so that this can take null. And when we get a response, we do is we call fn with null and response as many times. Okay. So when we have failure, we call this function with t and null. When we get response, we call the same function with null, throwable and response. Okay. How can we use this? We simply are going to do, let me just keep this part of the code ready so that you can use it anywhere else. Inside enqueue, we do rfcb. Do rfcb, and rfcb takes a throwable t and a response resp. Okay. So here is exactly the usage of a lambda function, rfcb t resp. Now we get the throwable t only when there is an error. We are only dealing with the response here, so we write this album.set albums response.body. Okay. Obviously it could be, response could be null here. Okay, so we can do is wrap it out with a function called let, which works like this: response dot let. Inside the let block, the value of response is available as a variable called it. So this let block will run only if response is available. Response dot let, and inside the let block I do this it dot body. Oh, sorry, it dot body. And if you want to go a little inside, you can do response dot body dot let, and in that case we can simply write it here. Okay. Now this is a very type safe syntax, is that if resp does not exist or if body does not exist, this part of the code is not even run. This is similar to basically putting an if else condition and checking whether the value of resp is null or not, value of body is null or not, and then executing your code. Instead of that, you can use the let function. Okay, so let function is defined inside Kotlin like this. It's an inline function. It takes let, and inside let, whatever object you are doing let on, t dot let if you are doing, so inside that the variable t is available. Okay. Now if you actually wanted it to look like body, so you could do it like this: b arrow and then use b here. Okay, but if your lambda expression consists of only a single argument, which is your lambda is purely x lambda, it is not a lambda xy, in that case you can even omit this part in Kotlin. and simply use the parameter it. It stands for the parameter on which the lambda is operating on. Okay, so simpler syntax, simpler syntax. Okay, write this concat that there. Yeah. Okay, so we can reduce a lot of code like this in all of the calls. Let's check that out. Albums activity, similarly for post activity, what we'll do is remove all of this. A lot of code here. Remove all of that stuff. RFCB P resp returns resp dot body dot let, and inside the let body post adapter dot set posts it. Okay, so like that you can reduce that for the other ones as well. To do's activity, same stuff. RFCB T response, if response exists, if body exists, then let to do's adapter dot set to do's it. And finally same stuff for the users. Okay, so reduce the enqueue calls. Let's write that. I think this text is a little too invisible. FCB like this. Okay. Okay, so that pretty much brings us to a very complete Android app written largely in Kotlin. Okay, things like interfaces, you can let this be in Java, because even if you convert this to Kotlin, you're not going to benefit in any way in reduction in size or anything. So always keep in mind that first of all, to understand Kotlin we need to understand Java, because Kotlin runs on the JVM. Secondly, a lot of my students have been asking me that whether Java will be replaced by Kotlin or not. That is never going to happen. It's just not possible to happen. Android has got millions and millions of lines of framework code written in Java, so Java is not going to go away anywhere. You can still, for example, the same iOS example, Objective C has not gone anywhere. A lot of the famous libraries are still written in Objective C. Java does have its own advantages, a lot of them. So the point of Kotlin is to use it, mixing it with your Java code, and wherever you know that using Kotlin code will do any one of the following things: reduce the number of lines you're writing, make the code more readable, or you get some advantage using functional programming and lambdas. Then you can move to Kotlin for those specific parts. If there are other parts of your code where Java is perfectly fine and moving to Kotlin does not give you any large advantage, you can keep those parts of your code as Java, and there is no problem with that. Okay, so that's the way to basically use Kotlin in Android. Um, you can also do this thing is check out some very nice Kotlin related resources. So one of them is Anko. Okay, so Anko is this library created by the Kotlin team itself. It's created by Kotlin. It's available on GitHub at Kotlin/Anko, and it gives you a lot of really nice additional things on top of Kotlin. So for using Anko, you will have to do is you will need to add these lines into your Gradle, okay, dependencies. Org.jetbrains Anko common. Okay, you will need to use Kotlin and then add Anko commons. And along with that, inside Android Studio, there is an Anko plugin. So you install the Anko plugin. If you want to use Anko, you will have to use Studio 3.0 or above. 2.3 won't work out. Okay. So 3.0 you will have to use because it crashes, I think, on 2.3 if you want to use. Anko brings you four very nice things. First of all, intents. How intents work in Anko? Common code that we all have written a lot. I equal to intent this some other activity dot class. It's written in Kotlin itself. Put extra, set flag, and start activity. You can do this in a single line in code like this. Start activity, intent for some other activity. In the brackets, we can write all our put extras, id to string. If there are more extras, you can do comma and so on and so on. Most of the flags are available in form of functions inside the Anko intents, so you can just write this 4 lines inside the single intent. Other than that, you can also do is you can use some of the pre-made intents: make call, send SMS, browse, share, email. Really nice. Okay, it adds you a very nominal overhead, I think 70-80 KB for the Kotlin library, and it gives you so many nice methods. That aside, there is dialogues and toasts. Sending dialogues and toasts, there is a DSL for that. DSL means domain specific language. So there is a specific way of creating dialogues like this. You can do toast just like this: toast hi there, toast r.string.message. Okay, toast will automatically take the name of your class as the tag. Okay, alerts work like this: alert, text of the alert. So this is the title, this part is the message. Okay, then yes button shows a toast, no button does nothing, dot show. Very nifty little domain specific language for showing alerts. Okay, if you want app compat, you can do alert, app compat, some text message show like this. So very little code to write for doing basic stuff like alerts and toast. But the big deal that why Anko is used is for the layouts. Now in Anko, you do not need to go into XML because XML is slow. Okay, in Anko you can directly define layouts like this. Vertical layout is a linear layout in orientation vertical. Inside that you create a edit text, create it name. You can do name.text equal to something you can change very easily. So you are basically creating data just like this. In Java, it's a very long process because you actually do is you create a new view, then you call add view. Inside add view, you pass on the view like that. So Anko layouts are very nice. If you're using Studio 3.0 and use the Anko plugin 0.10, you will also get previews of your Anko layouts. Now that is something that when you write your XML code in Java, if you delete all your XML inside your app and write all of your view code in Java, you won't see preview of that. But Anko has got previews also. So how Anko layouts work, there is a long article on that. This is the Kotlin code for creating a new layout. Okay, You create an activity, then you create a layout, then you set a orientation, then you create a edit text, you create a button, you create a text for the button, you set on text listener, and then you add view, these two. In the DSL, it's simply vertical layout, name, edit text, button, say hello, on click, toast. Very nice way of creating layouts using Anko. Anko is not on the very stable side of things. So if you are writing production apps, you want to run on very different kinds of phones that might not have Java 7 supported on them, which is basically lower than Lollipop. So in that case, you should not use Anko. But if you are developing for new versions of Android, you can use Anko. A lot less code to write, and code looks really sweet. Okay. And finally, Anko has a SQLite plugin. Again, very easy to use cursors. Okay, so you can do queries directly like this: db.select column name where, this is your where query, do exec parse list, and it creates a list for you. Okay, so these are all very nice things that Anko provides. Anko stands for Android Kotlin, ANKO. Okay, it's created officially by the Kotlin team, and a lot of commits on Anko is by Google developers as well. So it is very officially supported, and it's going to improve over the time. Okay. Yeah, I guess that's it. If you want to see some really advanced use case of Kotlin, just before starting this webinar, I was trying to see if using Kotlin we can reduce the fact that all of our adapters look the same. They all look the same. They have on create view holder, on bind view holder, they have a view holder, and then there is a bind view function inside them. All of them look the same, lot of common code. Can we reduce this code? So I was trying to figure out if that is possible or not. Okay, so that is actually possible. Let me just show you how that is possible. You can actually read up on this. You can see the code that I have written. Not sure if you'd be able to understand it or not, but I will just give you a quick explanation before ending the webinar today. So the way we created a retrofit extension, right? We created something like this. We created a helper for retrofit like this RFCB, and it reduced the amount of code that we were using inside the enqueue calls. That we can do with recycler view adapters as well. Now, what this code does is, I'll just give you a quick overview. Might not explain it a lot, but let's just go through it. So I have taken an abstract class called versatile holder. This versatile holder takes a generic object type, and in the constructor an item view is passed, and there is a abstract function, unimplemented function bind view, which takes an object of object type and an item view of view. Okay. So this versatile holder is going to be our view holder. This extends recycler view.view holder. This is the view holder that we are going to use everywhere. Okay. Then I have created a function called create adapter. Okay. And create adapter takes quite a few things. It takes a function called data update, which takes object type and view, item layout ID, an object list, which is the array list of the objects, and it extends recycler view.adapter. What this does is it returns an object that extends recycler view.adapter, and this create adapter creates adapters for you. Okay, and inside that the on bind view holder and the create view holder are already defined. Okay, and we are using this versatile holder as our view holder. You can read this in detail. Just run this on your project and you will understand how it works. Now, how it really works is we do not use the adapter anymore. We remove the adapter line. We have removed this adapter line from here. Okay, and what we do is we do rv album list.adapter is equal to create adapter. And we call create adapter. with generic type album, because we are creating a list of albums in this place. Now this create adapter takes this generic object type. Now this is the type of the objects which you are putting inside each item. So we do create adapter. Inside create adapter, our first argument is this lambda, which has album and view. Why? You can take a look. First argument takes an object type and view. Okay. Object type was this. So an argument of object type and an argument of view. And inside this function, what I am doing is I am defining what bind view does. Because this function is data update function. When does this data update function get called? You see that this data update function is called inside bind view. Okay. So I define what is supposed to be done inside bind view inside this lambda function. Then I give two more arguments, the layout, which is to be used for every list item, and the array list of my albums. Now this I have created here. Now whenever I get a response, I clear my array list, I add the collection to my array list, and I do album list.adapter.notify dataset changed. Now this is the code of my activity. It also contains my adapter, which also contains my view holder, which also contains my recycler view. So just with this much code, you can create the entire albums activity. Okay, so this might be a little confusing for some of you people. You can go and take a look again at how lambdas work properly, and come back and look at this code, and it would make a lot more sense to you. So this is pretty much all from my side. We can do a follow-up on this maybe next month, or next week another webinar with some more advanced use cases of Kotlin, like using Anko for one, using DSLs for creating the views, and creating DSLs for SQLite. We will take a look at them on a later date. Before signing off, if anybody has any particular thing that they were unable to understand, you can just ask them, and I will be signing off in 2-3 minutes. Okay. Okay guys, I'm just going to end the webinar right now, and you can have my email ID, which is this. If you want to ask me about anything regarding this webinar, or as such about Android in general, so I'm available on my email ID, a@cv.lk. Okay, so that's my email. Okay, most of the code that we have written here is available on github.com/coding-blocks archives. There are other stuff as well there, you can check them out. My personal GitHub is on github.com/championswimmer. I am available on Twitter as Champion Swimmer if you want to reach out. Okay. So if there was anything you are unable to understand, whether during a live webinar or anybody who is going to watch this webinar later on, you can contact me on my email ID, ask me if there was anything, or you can put a comment on this video itself. Okay. So bye guys. Good night and sweet dreams.